Welcome to our journey through the amazing world of chemical reactions. You know, when I was a kid, I had this chemistry set. It wasn't as complicated as what we're going to talk about today, but let me tell you, it opened up a whole new universe of possibilities. Today, we'll explore 5 different types of chemical reactions that you encounter in everyday life. From the food you eat to the air you breathe, chemical reactions are happening all around us. You might be surprised to learn that many of the things you take for granted, like the batteries in your phone or the way yeast makes bread rise, are all thanks to these fascinating processes. So put on your thinking caps and get ready to explore the incredible world of chemistry. And remember, safety first, everyone. Always wear your safety goggles when experimenting. Let's kick things off with synthesis reactions. In the simplest terms, a synthesis reaction is like combining the ingredients to bake a cake. You take 2 or more simple ingredients like flour, sugar, and eggs, and combine them to create a more complex final product, a delicious cake. In chemistry, a synthesis reaction is all about combining 2 or more reactants to form a single, more complex product. Imagine taking a couple of building blocks and snapping them together to create a bigger structure. That's synthesis. A classic example of a synthesis reaction is the formation of water. We all know that water is made up of hydrogen and oxygen. When you react hydrogen gas with oxygen gas, boom, you get water. It's that simple. But synthesis reactions aren't limited to just simple molecules like water. They're happening all the time in the world around us. For example, plants use sunlight, carbon dioxide, and water to create glucose through photosynthesis, which is a complex synthesis reaction that's essential for life as we know it. These reactions are like the master builders of the chemical world, constantly creating new and interesting compounds. Pretty neat, right? Now let's talk about decomposition reactions. Remember that cake we talked about earlier? Well, a decomposition reaction is kind of like the opposite of baking a cake. Instead of combining ingredients, we're breaking them down. Imagine taking that delicious cake and separating it back into its original ingredients, flour, sugar, eggs, and so on. That's what happens in a decomposition reaction. We're taking a complex compound and breaking it down into simpler substances. One of the coolest examples of a decomposition reaction is the electrolysis of water. By passing an electric current through water, we can break it down into its constituent elements, hydrogen and oxygen gas. It's like magic, but it's science. Decomposition reactions are also essential for many industrial processes, like the production of metals from their ores. By heating up these ores, we can decompose them and extract the valuable metals inside. Decomposition reactions might sound a bit destructive, but they play a crucial role in many natural and industrial processes. Remember, sometimes you need to break things down to build something new. Okay, get ready for some chemical trading. In a single displacement reaction, it's all about one element swapping places with another element in a compound. Think of it like a game of musical chairs, but with atoms instead of people. Imagine you have a couple dancing at a party. Then, someone else cuts in and takes the place of one of the original dancers. That's kind of what happens in a single displacement reaction. One classic example of this is the reaction between zinc metal and hydrochloric acid. When you drop a piece of zinc into hydrochloric acid, the zinc displaces the hydrogen in the acid, forming zinc chloride and releasing hydrogen gas. It's a real gas. These reactions are super important in many industrial applications, especially in the extraction and purification of metals. They're also used in things like batteries, where chemical reactions are used to generate electricity. So next time you see a battery powering your phone or a flashlight, remember that it's all thanks to some clever chemical trading going on inside. Get ready to do-si-do, because it's time for double displacement reactions. In these reactions, 2 compounds switch partners, kind of like a square dance in the world of chemistry. Imagine you have 2 couples dancing. Then, they decide to switch partners, and now you have 2 new couples dancing together. That's the basic idea behind a double displacement reaction. A great example of a double displacement reaction is the reaction between silver nitrate and sodium chloride, which is just table salt. When you mix these 2 clear solutions, something amazing happens. They react to form a white precipitate of silver chloride, leaving behind sodium nitrate in the solution. Double displacement reactions are essential in many areas of chemistry, including the production of fertilizers, the treatment of wastewater, and even in the formation of rocks and minerals. So, the next time you see a beautiful rock formation or sprinkle some fertilizer on your plants, remember that double displacement reactions might have played a part in their creation. Let's turn up the heat and talk about combustion reactions. These reactions are all about burning and releasing energy in the form of heat and light. Think about what happens when you light a candle or start a campfire. You're initiating a combustion reaction. In the case of a candle, the wax reacts with oxygen in the air, producing a flame, heat, and light. Combustion reactions always involve a fuel like wood, propane, or gasoline, and an oxidant, which is usually oxygen. When the fuel and oxidant combine in the presence of heat, they react to produce carbon dioxide, water, and a whole lot of energy. These reactions are essential for our everyday lives. They power our cars, heat our homes, and cook our food. However, it's important to remember that combustion reactions can also have negative impacts on the environment, especially when we're talking about burning fossil fuels. Combustion is a powerful force, and we're constantly finding new ways to harness its energy while also minimizing its environmental impact. Thanks for joining us on this chemical adventure. We've explored the fascinating world of chemical reactions, from the simple combination of elements to the powerful release of energy and combustion. Chemistry is happening all around us, shaping the world we live in, and even the air we breathe. Remember that chemistry is more than just equations and formulas. It's a way of understanding the world around us, and appreciating the incredible transformations that happen every day. Don't forget to like, subscribe, and hit the bell icon for more exciting science content. Keep exploring, stay curious, and never stop learning.